just use Excel. So that actual probability is calculated, and what I'll do is after I work through all these examples, I'll show you in Excel the same calculations, and I will have attached to various emails I send out an Excel file that has contained in it the very examples that we use here. The function in Excel is equals norm dist, just so you can see it. And it'll ask you for 3 values, x. The next thing you tell it is mu. The next is sigma. And then it'll ask you whether you want it to be cumulative or not, and you just write the number 1, which is the same thing that nerds use instead of the word true. So this will tell you everything you need to know. Just tell it x, mu, sigma, and 1, and it'll tell you the probability to the left of whatever x value that is that you gave it. So if this is x, it'll calculate this area for the particular bell curve that you're interested in. So what I'll do is I'll talk through a number of quick examples, and then the calculation part will all be done in Excel, and I will have an Excel spreadsheet with these examples worked out, given to you and presented to you via the distribution list sometime soon, probably as soon as I get this lecture posted on our YouTube site. Awesome. Welcome to the future. So let me just give you a couple quick examples. There's this guy who's known as Jack Welch. He very famously said that every year you should take the top 20% of the managers and give them a reward, and then take the bottom 10% of his managers and give them a new job in some other company by telling them they're fired, and then everyone in the middle just, they get to move on in a regular way. So if we could take a random variable x, which is distributed sort of like a bell curve, as skill tends to be. Let's say that there's a scale that we rate managers at, and the average is 60, and the standard deviation is 18. So with a probability distribution that looks like this, I might want to ask a bunch of questions. Let's say you, being awesome, got a managerial ranking of 92, and you might want to ask, is 92 high enough to put me in the top 20% or maybe the top 5%? If this is the distribution of scores, does a score of 92, where does that put me relative to the others? So what we do is we take this normal distribution that has a center of 60 and a standard deviation of 18, and we ask, 92 is over here somewhere. Is it off the charts, or is it really close? If I put 92, I want to ask, what is the probability that of being greater than or equal to 92? Piece of cake. To do that, I would just ask Excel and say, well, what is the probability of being less than 92? Because that's the way Excel is programmed. It always tells you the probability to the left. But I have a particular wisdom about this, which is that the total probability of something happening has to be equal to 1. And if that's true, if this is about, and it is, approximately 97%, then that's going to tell me that this area has to be about 3%. So the function I would use in Excel is something like this. To calculate this area, I would say that should be equal to norm dist. Sorry, I already forgot. I want 1 minus norm dist for a normal distribution, value of 92 for x, a mean of 60, a standard deviation of 18, and cumulative should be set at 1. And these are approximately, with a little bit of rounding, the numbers that you should get. It should be about 3%. Alright, does that make sense? I'll work through a number of other examples, and then there are some problems in the Klebanoff textbook that you have, the thin managerial statistics textbook. And in chapter 1 there's about 100 problems, which I will send you, okay, maybe 20. I'll send you the answer key so that you'll have those problems worked out as well. Another interesting question and skill that we'll have that we can do in Excel is this. Given a normal distribution, let's say that intelligence, and an intelligence test, you tend to see this sort of thing. We have an average of 100, and the standard deviation varies by test, but let's say it's about 15. And my question for you is, have you possibly heard of Mensa, the high IQ society that lets super nerds know exactly how nerdy they are? To get into Mensa, you have to be in the top 2% on an intelligence test. But there's a sister organization that you may be less familiar with. It's called Densa. And to be in Densa, you have to be in the bottom 2%. So here's my question. How dumb do you need to be in the bottom 2% on the intelligence test? There's a number of ways to do this, but Excel has a nice built-in feature, which is norm inv. And for a norm inverse, you have to tell it the probability that you want, which would be 2%. And then the other features are, it'll ask for the mean and standard deviation. So with those three values, they'll tell you that for this particular distribution, it'll tell you the value of x that gives you 2% area to x's left. And that should be about 69. So if your intelligence test score is 69 or less, you have qualified for Densa, the Dumb People's Society. I'm sure any Sasson student is more likely to be in Mensa, the top 2%. Hopefully 100% of you would be more likely to be in Mensa. So here's my question. What's the probability, what value of x, what intelligence test score puts you in the top 2%? So to get that, you can do it two different ways. The first is using the norm inv function in Excel. Norm inv, and it's asking you for a probability to the left. So if I want 2% probability to the right to be in the top 2%, that means I've got 98% probability. And then it'll ask you 98% probability to the left. Then it'll ask you for the mean and standard deviation. And if you put that in, Excel will tell you it's probably about 131. Roughly, it's rounded off. Excel will go to 15 decimal places. I will go to 0 decimal places. You don't need to actually do that calculation if you've already done the Densa calculation. You can see that it's a symmetric. That is, if you put a mirror in the middle here, there's just as the same shape on this side as it is on this side. So if the center is 100,